All right, welcome. So this is Mr. Hale here, and today we're talking about linear systems. So before we do a linear system is two equations with two unknowns. At this point, we've only done one equation with one unknown. And what we're going to do is start out by just reviewing some graphing really quickly. This first one I will do in red. This is in slope-intercept form. We're going to locate the y-intercept, which is 1. And then we are going to count up 3 over 1 as the slope, so 1, 2, 3 over 1. And we're going to draw that line. And we'll do the best we can. So at home it should look better. You have a ruler or some kind of straight edge. So that's when it's in slope-intercept form. The second one is in standard form. You can solve for y here and put it in slope-intercept form, but I find it much easier when it's in standard form to just find the x and y intercepts. So the x-intercept is when I make y 0. If I plug in 0 for y, I get x equals 8. And then if I go ahead and plug in 0 for x, plug in 0, I get 4y equals 8, so y must equal 2. So let's plot these points. I go over 8, up 0. And I go over 0 up 2. And I'm going to draw my line. Again, it's a little off. At home, yours should look better than that. All right, the last type we have is one of the special cases, which are horizontal and vertical lines. We know that's the case when we are missing either the x variable or the y variable. So this is missing an x. We have a y equals 7. Since it's y equals, it's a line that goes through the y-axis. The only type of line that can go through the y-axis is going to be a horizontal line. And I'm putting it here because it has to go through 7. We don't need to plot any points for this one. We shouldn't have to at this point. All right, so that's just a really quick review of how to graph something in y-intercept, slope-intercept form, standard form, or a horizontal/vertical line. So let's move on to what we're talking about today. And here's an example of a linear system. This is two equations with two unknowns. So everything we do from here on out is going to be solving two equations with two unknowns. And the point here is, let's take a look at the first one. I just have some random numbers that I picked here, 0 through 5, just to get an idea of some points that are on this line. If I plug in 0 for x, I get 2 times 0 plus 15, which is 15. Then if I plug in 1 for x, if I replace x with 1, I get y equals 2 times 1 plus 15, which is 17. Now let's look at the 2. If I plug in 2 for x, I get 2 times 2 is 4 plus 15 is 19. And we should see a pattern here. We're adding 2 every time, and that happens to be the slope. So now I can complete this table because we're counting by ones on the left side. I can go 21, 23, 25, and so on. So these are just an example of 6 points that would be on this line. Remember, there's an infinite number of points on each line. But what we're trying to do is find maybe a point that these share. So all these in green are solutions to just the first equation. But we're trying to find a solution to both equations at the same time. Now let's just look at the second equation. If I plug in 0 for x, I get 4 times 0 plus 7 gives me 7. Instead of figuring out the rest of these, since I'm counting by ones, let's just use the same pattern as before. But now instead of adding 2 each time, my slope is 4, so I can add 4. So I get 11, 15, 19, 23, and 27. Now in red, these are all the points that solve the second equation. So remember, there's an infinite number of points that solve the second equation, and an infinite number of points to solve the first equation. But what we're trying to do is find that one single point that solves both equations. And that is if you just look at this row. When I plug in 4, I get 23 for both equations. So the point 4, 23, we call the solution to our linear system. All right, so that's the idea. We won't be using tables. We're going to be using graphing, but I just wanted to give you an idea of what it means to solve a linear system. So the answers to all of our questions, all of our problems from here on out are going to be in coordinate form. Unless we're answering a word problem and then we want to answer it, specific to what the question's asking us. But we're always looking for this coordinate that solves both equations. So today's method is by graphing. There will be some algebraic methods that we talk about in later videos, but today we're going to just talk about graphing. If you go to your next slide, I realize I made a mistake. Please write these equations down instead, and cross out the equation that you have. That was the one from the table before. If we try to solve that, it'll go off our grid, and it'll be kind of a pain to try to rescale it. So let's take a look at this new one. Y equals 2x plus 4. Let's graph that. The y-intercept is 4, and the slope is 2. So I go up 2 over 1. Now, one thing I'd like us to do is plot more than 2 points. I'm going to go up 2 over 1 several times, and that is because when we graph these, we want to be as accurate as possible, and sometimes a ruler or a straight edge doesn't always allow that. So just plot, maybe a bunch of points here, and then I want to put my line through it. So this represents an infinite number of points that will work with our first equation. Now the second equation, let's take a look at that. That y-intercept is 10. So I go up to 10, and our slope is -1. There is an imaginary 1 in front of here, over 1. So it's down 1, right 1. So I'm going to go down 1, right 1 a couple times. Once you look at that, if I go down 1, right 1 again, that point's already there for me. So we'll talk about what that means in 1 second. So we keep going. I think I have enough to make a nice, accurate line. So if we look at in red, it represents an infinite number of points that solves the first equation. And in green, that's an infinite number of points that solves the second equation. What we have is one point that solves both. And what we call that, geometrically, we would call that the intersection. We're all familiar with that word. And the intersection here is over 2 up 8. So that means the point 2, 8 is our solution. So we are simply graphing the lines and finding the intersection. So let's move on to the next one. Oh, these are both in standard form. So first I'm going to do in blue, I'm going to find the x and y intercepts. So you can always do this to find the x and y intercept. If I plug in 0 for y, I get -x equals -7. That means positive x must equal positive 7. And if I go ahead and I plug in 0 for x, I simply get y equals -7. So I get 7 and -7 for my intercepts. So I go over 7, and then I go down to -7. And I want to draw my line. This one, when it's in standard form, we are going to have to rely on the best we can as far as drawing our line. That's not great, but we'll deal with it. And then in green, I'm going to find the x and y intercepts of the second equation. So 0 for x, 0 for y. If I plug in 0 for y, I get x equals -8. If I plug in 0 for x, I get 4y equals -8, so y is -2. So I go over to -8, which is here. My y-intercept is -2, which is here. And in green, I'm going to do the best I can. And what we want to do is find the intersection, which is right around here. I did a poor job here graphing this. So if this happens, let's pick a point that's near it. Let's say this one, because again, let me actually just redo this line, because I think that's really off. Let me redo both of them. Maybe. All right, so the one in red is there. And if we do the one in green, that's still off. Ooh. So you can see how you can have a little bit of difficulty with this. Let me actually just draw the lines for these. So this should be much better. All right, we're having some difficulty here. I apologize. All right, that's one, and then the other. Right there. So now we can see that we have a clear intersection. So if I go over 1, 2, 3, 4, down 3, so 4, -3 would be our solution. And we can see if we check, if we plug in 4 and -3 here, -4 minus 3 is -7. And 4 plus 4 times -3 here does give us -8. So 4 minus 12 is -8, -4 minus 3 is -7. So with the graphing, you can see there can be some issues here. We want to pick the point that is the intersection, but if we don't graph it accurately, so I made a mistake of just trying to draw this in. What I should have done from the beginning is use the tools I have available. So what you have available is a ruler or a straight edge. If you do that and you're more accurate, your intersection is going to work. So when you graph, you want to double check that the intersection you have actually works. You do that by plugging in the x and y value into both equations and making sure that both work out. All right, so moving on, we have a real quick. There, if you look at the first one, that's an example of what we've done so far where there was one solution. But not all lines have one solution, because if you think about how lines intersect, this possibility is you only see one line there, but there's actually two. The lines are on top of each other. So therefore, we have an infinite number of solutions. And then the last one, you have parallel lines. They're not going to give you any solution because parallel lines do not intersect. So let's take a look really quick at examples of these. The first one, in red, I'm going to plug in 0 for x, 0 for y, and then 0 for x. 0 for y gets rid of this term. 2x equals 12, I get x equals 6. If I plug in 0 for x, it gets rid of this term. -3y equals 12, I get -4. Plot those. Six, 0, 0, -4. Let me actually do a little better job here and graph this line. And I go, and in blue, I'm going to find the x and y intercepts of my second equation. So 0, 0, plug in 0 for y, and I get x equals 6. Plug in 0 for x, and I get y equals -4. Uh-oh, look what I got. I've got the exact same y and x intercepts. When I plot those, I'm going to get the exact same line. Since I'm not going to plot the line again. If I plot it on top of itself, it's going to look exactly the same as the graph does now. So therefore, every point that's on this line is going to solve both of these equations. So there's not just one answer, there's an infinite number. We're not going to sit here and list everyone out because it'll take forever, literally. All right, last case that you could get by graphing. So we're back to slope-intercept form. let's take a look at this first one, and what I'm going to have is the intercept of 7 and a slope of -2. So that means I'm going to go down 2 over 1, and when it's in slope-intercept form, it allows me to be a little more accurate, especially using a smartboard. I'm going to go down 2 over 1 several times, and then I can even use the line function, a little more accurate. So there's my line. Now I'm going to look at the second equation. All right, so this equation. And this one is an intercept of 1, y-intercept of 1. And I'm, again, going down 2 over 1. Well, what we should be thinking about is immediately these have the same exact slope. We've learned before that only a certain type of lines have the exact same slope. Those lines are called parallel lines. So if I draw this line, it should be easy for me to see that these lines are in fact parallel because they look at number 1. Also, they have the same slope. So if they continue, if they have different starting points, meaning the y-intercepts, and in both directions they're going up and over at the same rate, then these lines will never intersect. Since our goal of this problem is to find the point at which these two lines intersect, or the point that solves both equations, that will never happen. So in this case, I write no solution. All right, so that's it. So just to recap really quickly, when you're given a linear system, the one option we have, which we talked about today, the other options algebraically we'll talk about later, but today and in class, next 2 classes, you're going to be solving these by graphing. And what you do is you graph both lines. If the lines intersect, the intersection, the coordinates, the x and y coordinates of the intersection are the solution to the linear system. If the lines don't intersect, meaning they're parallel, then there are no solutions. And if the lines, if both form the exact same line, then you have an infinite number of solutions. So you have 3 possibilities. All right, so please study your note sheet, come to class on Friday ready to go, and we will do more practice when we get into class on Friday. All right, see you then.